let's say this is a problem statement. You will be given an integer array, and we need to find out the number of combinations you can make from this input array to reach target. Let's say here the array is 2, 3, 6, 7, and the target is 7. You can repeat the number any number of times. So that's what the problem statement says. So you can repeat the frequency of number any number of times. So let's say in order to make target 7, what are the possible combinations you have which are to be returned? So if I repeat 2 twice and 3, so 2, 2, 3, the sum of these three elements becomes 7. Similarly, the individual 7 also becomes 7. So let me walk through it. Yeah, so this is what the problem statement says. So you have given an array 2, 3, 6, 7 and target 7. So there are we need to find out combinations. You can repeat the number any number of times. So let's say I repeat 2 twice and 3. So the sum of these three elements will be 7, and you can have individual one 7. So we need to return these two combinations. So how do you solve it, right? So it's a very good technique on backtracking. Let's see how can we approach it. So you don't know, right? You don't know the target. You don't know how to reach the target. So you need to see all possible solutions. So I'll just write a simple diagram, as we already have little idea about backtracking. So we can directly uh, tweak into the indexes. So let's say first I will start with 2. Okay, so first I will start with 2. So first this is index 0, index 1, index 2, index 3, right? So first let me start with the value 2. Then what I can do, it means I am starting with index 0. Okay, I am starting with index 0. I could see that the sum of current sum is equal to, I think I don't need to note down, but you can understand that, right? The current sum becomes 2 because the elements present in this subset is 2. Now, what I do, so I have a choice. So I have a choice to start. I can pick up any index, right? I want to get the combination sum. So I can pick up any choice. Either you can pick up index 0 or index 1 or index 2, index 3. So this is your choice. You can pick up any one of them. So let me start with index 0. So let me start with index 0. So once I start with index 0, so at index 0 I have value 2. So let me repeat it. So can I repeat is because you can repeat the number any number of times. So that is what problem statement says. So I repeat the same number 2. Okay, so then the sum becomes 4 now, because here if you closely see the sum becomes 4, here it is 2. Now again I repeat the number. Now let's see, I can repeat the number. Now the sum becomes 6. Again I repeat the number. So if I repeat the number, then the sum becomes 2, 2, 2, and 2. So the sum becomes 8. Now, if you closely see, this is your sum which is greater than target 7. So that I don't want to proceed further. So definitely I don't want to proceed further. So I can exclude it. Now, if you closely see, I traversed only with index 0, right? So whatever you see, this is also having complete index 0 elements. This is also having complete index 0 elements. If I extend index 0 furthermore, if I extend index 0 furthermore, definitely this will not, this is reaching out of the target. So that this is where I need to backtrack. So whenever I'm backtracking, so the standard principle, right? So what are we doing here? So this is your current list. So first, initially in the current list, you added an index 0 element. Then you move further, you are adding same element, and you move further, you are adding same element, and you move further, you are adding same index 0 element, and you understand that the value is sum is 8, which is greater than 7. So so you just backtrack. So whenever you are backtracking, so you are removing the last element from the last element from the current list, so that obviously this is been removed. Again, you will get this one. Hope you are following me, right? Everyone, please. Right. Good. So now let's move. Let's move on. This way I can get it. Yeah. So let's move on. Uh, Now it means if you closely see, I repeated index 0 till here. I repeated index 0 till here. And if I repeat further, I'm exceeding the length. So what I will do, let me let's not index 0. So let's not repeat index 0. So that obviously what is the choice I have? I need to go with next index. So okay, let me go with the next index, which is index 1. So if I go with index 1, then it is going to 2, 2, 2, and at index 1, what is the value I have? Value 3. Okay, so I have value 3. Now, if you closely see the sum of these elements, 6 plus 9, 3, which is 9, which is greater than 7. So again, which is reaching out of the target so that I can exclude this. And let me move further. Let me move further. So I'll go with index 2. So at index 2, I have value 6. Obviously, 2, 2, to 6. So obviously, which is also reaching 6 plus 6, 12 greater than 7. So which is also not reaching the target, which is also greater than target, so that I cannot forward it. And let me move further. Let me move further. So I'm going with index 3 now. So if I go with index 3, definitely it is going to be 2, 2, 2. I'll have next element as 7. So obviously, if you closely see, which is also reaching the target, so which is also greater than the target, so that I can exclude this combination. So if you understand that, from here, if I see any possibility after repeating index 0 3 times, if I go with any possibility, I cannot reach the target. So definitely, I cannot reach the target. So definitely, this is not the possible path. So that with this, you can't reach any target. So that we are done with this. So let me take this aside. Just to first, we are done with this possibility. So that we couldn't find any target here. Okay, let me make it. Let me park it. Aside. And actually what we did, so we were what we did earlier, so we were extending furthermore, and we seen all possibilities, none of them were found, so that we just skip it. So now again you need to repeat the same operation for next one. So here, this is the one which is repeating index 0 twice, right? Now let's move further. So we have seen after extending index 0 furthermore, and we have seen all possibilities, none of them were able to solve, so that we are just crossing it. Now let's move further. So what you do, so now again you have three possibilities from here, so you can choose index 1 or index 2 or index 3. So let me choose index 1. So if I choose index 1, so definitely it is going to be 2, 2. At index 1 we have value 3. So you have value 3, so which is reaching the target. So definitely you find out a solution. So whenever the current sum is equal to target, you find out a solution. Whenever you found a solution, take that value and add it to the result. Okay, so I have added this value to the result. Now if you closely see the problem statement, right? If you closely see the problem statement, in the problem statement, it says that uh, all the candidate, whatever elements present in the candidates, all are distinct. So as all are distinct, so you don't need to explore furthermore, right? So once you find a possible solution with this combination, definitely you don't need to explore furthermore. So other combinations you don't need to explore. So definitely you don't need to traverse other combinations. Why? Because all are unique numbers, right? So with this combination, only this number will be possible. So if it is duplicate number, you can explore furthermore, so that you can stop the recursion, so you don't need to explore other things. You can stop the recursion and return to the caller. You can, while returning to the caller, you can remove this element. So you are explore, as you got the result, you didn't explore other solutions. You can return to the caller, so remove this element, and then this is also be removed. If you closely see, we have explored index 0. We have explored index 0 so from initial call, right? So this is what I'm trying to say. So initially what we do, we initiate a backtrack call with index 0. So with index 0, we are trying to explore this one. Then what is our choice now? We'll see the possibility of next index. So this is what it happens, right? Hope you are following me. So initially you can choose any index, right? So initially you are initiating this call with index 0. So our start becomes index 0. So from the start you are trying to explore further more. If index 0 is done, then let's move on to index 1. Same thing at index 1, again you have 3. Again you try to repeat 3, 3. Again you try to repeat 3, 3, 3. So obviously which is exceeding so that you don't go further. Then you try to repeat next value. So 3, 3, 6, which is exceeding the result. You don't go further. And again you try to repeat next value. So 3, 3, 7, which is also exceeding the target so that you don't go further. So that it means it means from this combination if you go further it doesn't work, so that let's try from this combination. So from this 3 you can try other value 3 comma 6, which is also exceeding the target, and you can also try 3 comma 7, which is also exceeding the target, so that none of the recursive call find the target, so that with 1 you couldn't find any combination. So let's go further more. So let me try with index 2. If I try with index 2, so what you do, same thing. So 6, then you repeat 6. So definitely which is exceeding the target. So that what you do, you don't repeat 6 again. So that you go to the caller from 6. What is the next element you have? 7. So you add 7, which is also exceeding the target. So it means there are no other ways to solve it. So definitely with index 2 also you couldn't find anything. Now what is the last solution you have? You are trying to look for index 3. At index 3 we have 7. So let's say you add 7. So that if you closely see, 7 is equal to target. So the current element is equal to target. So as it is reaching to the target, definitely you can copy this result. Okay, obviously you can copy this result. So just let me copy this result. Then you don't need to, of course, this is the last index. So even if you have elements, you don't need to explore furthermore, because all the elements are unique. Whenever you reach the target, you just explore this, you just return to the caller by deleting the last element. That's it. Did you understand the flow, everyone? I went little quick. Hope you get it. Perfect. Perfect. So, what is the time complexity? Can you please tell me? So, to understand the time complexity, right, you don't need to be super precise, but with common sense, you can derive it. So, what are we doing here? So what are we doing? What is the depth of your recursive stack? Can you tell me what is the depth of the recursive stack? Perfect, right? So the depth of the the depth of the recursive stack is, this is your target, and whatever minimum value that is the minimum target by minimum, right? For example, if the target is 8, minimum value is 2, the depth will at max will be 4, correct? Yes or no? You repeat 4 times, the depth at max will be 4. And now let's understand for how many elements this depth will be there. For how many elements this depth can be there? So when it comes to subset, right? So when it comes to subset problem, what we did, we take the current element, whether you included or excluded. So for every element, the depth will be only 2. For every element, the depth will be only 2, so that we took 2 power n. But in this case, how many elements the depth can be t power t by m? Do you think only for one element? More or less, more or less for all elements, right? If you consider as a, no, I understand your point. For example, if you have one, two, 1 2, then if the target is 8, for 1 depth will be 8, for 2 the depth will be 4, Of course, it is if it is depth is n, for other element it is n by 2, right? So this is how it is. But for other element it can be n by 4 and so on. I understand that this is n plus n by 2 plus n by 4 plus and so on. But in reality, altogether you can take it as n by some value which is equivalent to n. So that's how you derive the time complexity. Hope you are getting this point right. Everyone, please. So obviously the depth, right? So yeah, if you go to be precise, one will have n depth, other one will have n by 2 depth, other one will have n by 4 depth, other one will have n by 8 depth, and so on. But altogether, the summation you can represent it as n. So that obviously, in worst case, you can consider it as n. So n to the power t by m, where t is representing target, m is representing the minimum value. Now, now, if you closely see, let's say target equal to 8, then you have minimum value is 2, then you have 2 comma 2 comma 2 comma 2, right? So it means what does it mean? Okay, so target equal to 8 and n equal to 1. Yeah. So what I'm trying to say, more or less, right? More or less, what could be the length of this combination? More or less, what could be the length of this combination? The length of this combination, more or less, it can be equal to, it can be greater than or equal to given input length, right? So if you say this is the input length, if you take greater than or equal to given input length, right? Yes or nobody? Are you getting my point? For ex for example, you have target 8 and minimum value equal to, then what could be the length? So 2, 2, 2, 2. For example, if the target is 8 and minimum value equal to 1, then you will get 1 8 times, right? So 1 8 times. So, but most of the cases, the target which is more or less equal to the length of the given input array, right? Yes or no? The length of the given input array is 4. In this case, the length is 4, but in this case, the length is 8. But this combination will occur only once. All other cases, the length is more or less than or equal to n. So not greater than. So less than or equal to n. Correct? So so I can say it means the combination you could see, right? The combination you could see here also we got combinations, two combinations. If you take each combination which is less than or equal to given input n. So let's say I for you get you don't know how many combinations you get. For each combination, the length will be this one, n into n to the power t by m. So you can represent the same as n to the power t by m plus 1. So that's how you can just do that. Uh, hope this is valid, right? Okay. So, right. So this is which subset? This is not subset, right? This is combination. This is not subset. In subset, what will happen? This is how it is, right? In subsets, you have a index 0. Either it can included or it can be excluded. Either of the cases, you will reach to index 1. So here also you can include or exclude. Either of the cases, you will reach to index 2. Even this case also. But in this case, what is happening? You have index 0. First you include it, then you will try to include whenever you are reaching out of the target, then you exclude, then you will move on to the other index, right? So that's how you do it. So that's why the depth of this, right? The depth of this is going to be t to the power m, t by target by minimum value plus. So this can happen for n elements, so that because if all elements are smaller, then smaller than the target, more or less. It can be n plus n by 2 plus n by 4 plus and so on. For example, you see 8, you have elements 1, 2, 4, then obviously the depth here will be 8, here will be 4, and here will be 2. So that's how it is. More or less it is equivalent to n, so that n to the power t by m plus more or less each combination length less than or equal to n means the given input length, so that plus 1. So this is a time complexity. Hope you are able to get it right. Everyone, please. Array, backtracking time complexity, right? One of the most critical part, but you like it or you do not like. For Google and Facebook, this is the favorite choice for them. So if you are very unlucky, you come up with something very wide question. But if you are able to see, if you are able to explain on an average, right, they will be happy for it. So you don't need to be so precise. Okay. Now we understood the time complexity as uh, n to the power t by m plus 1. And what is the space complexity with respect to stack frames? Stack frames. Let just tell me what is the stack frame size with respect to stack frames. How many stack frames will be active at any point in time? Yeah, tell me what is that? How many stack frames can be active at any point in time? Let's say, so one thing for sure, T by M definitely active, right? T by M definitely active. Plus, how much can be? For example, let's say you have 1, 1, 1, 2, 4, and you have value target 8. Then there will be 8 ones, right? 8 ones. Ones will repeated 8. Then you got the target. Then from here you go on to 2. From here you go on to 4. And this is gone. This is also not possible. Then you go to next one. This is seventh one. This is sixth one. Assume sixth one, you go on to 2, and again you find out. So what do you think here? What is the maximum stack frame can be active? Yeah, yeah, 2 and 4. Let me draw it. Maybe I made it little confused. But assume you have target 8 and 1 repeated 8 times, right? Yeah, yeah, I understood. You have repeated 8 times. Here you got 8. Now, once you get it 8, with this combination you got 8, and then you try 2 here. First, here it is 7, right? So with 2 you tried, with 4 you tried. None of them work. Then here the sum is 6, right? So here you tried with 2. So it is found so that you get this value. Again, you try here with 2. It doesn't, the sum is 7. Then again you try repeating 2, then obviously which doesn't work because it is 5 plus 7 plus 2, which is 9, but we required 8. Then we tried for 4, that also didn't work. Then you move further, so with 2 you try. Here if you closely see, the value will be 6. Again you go to 2 and the value will be 8. It means you found a combination. Then that's you found a combination, that's it. Then you try with 4, with 4, so values will be 4 plus 4, which is going to be 8. Again you found a combination, so that you don't need to explore furthermore. uh, that's how it works, right? Now what could be the maximum length you could see in this triangle, in this stack frame? What is the maximum stack frame you could see? It is T by M, right? So it is T by M. So even you explore other possibilities, but if you closely see, which is always less than T by M. So which is always less than T by M. Plus whatever possibilities you see. whatever possibilities you see, even in worst case also, even in worst case, what do you do? Even in worst case, you try to see with 2 and 2 and 2 and 2. Here it will fail. Then again, you try to see with 4 and 4. So if you closely see, this is actually taking more depth so that you can consider, you can simply written it as big O of T by M. Hope it makes sense, right? Yes or no? Ajay, any confusion here? Yeah, 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 yeah. But if you closely see this diagram, right? Uh, Comparatively, this is higher, right? So we take the higher one. Yeah, yeah. Okay. Now, with respect to result, how do you determine? Okay, so let me talk about how much of space it will take for result. How many combinations we can generate? Or you can explore on it. I too didn't spend time on math, but if you spend time on math, we can understand how many combinations we can generate for a given target. That math value is going to be the result. So, but if you want to speak roughly, if you want to speak roughly, also it is very tough, right? Because if you see this one, it was giving lot of things. So but even here also you will get a combination. And even here also you will get a combination. So it's really tough to calculate how many combination results you will get. So you give a try. Uh, I'm just leaving for result. Okay, this is cheating, Srinu. You should not do that. Huh? Fine. So can you tell me how to write the logic? Uh, So how to write the logic? Okay. So private void backtrack. Let me take this diagram aside. Okay. So this is what we are trying to do, right? So we initially, can't I make two at a time? Okay, so that's okay. So initially what we are trying to do, we are going to get the index and we are also getting candidates and we are also having target. What we do, so in this case, right, we are trying to sum up the target whenever target is each time whatever values you have, we take that sum of it and whenever it which is reaching the target, you can return it. Rather than that, we will subtract the target, right? So uh, the other way also you can do it. So generally, let me show it here. Let me take 2367, right? So you have 2367 and the target is 7, right? So what you do, first you will take 2 and the remaining target will be 5. Then again you take 2, the remaining target will be 3. Because you just subtract this 2 from the target so that for the next recursive call, initially the target is 7 with empty subset. But you consider current 2, then remaining target becomes 5, and you again consider the 2, remaining target becomes 4 because this sum will is 4, right? Again you consider 2 and the remaining target will be 1. And if you consider 2 again and the remaining target will be less than 0. So as it is less than 0, you break it and you try considering value 3, then again the sum, right? So 1 minus 3 it becomes minus 2 which is less than 0, again you break it. Similarly 6, similarly 7, all will be all will not work. Then again from here you have 3, right? So it means you tried with this possibility and you consider this element 3, and 3 minus 3 which is 0, the target is 0, so that it means you found a combination, then you just take that result. So instead of taking instead of considering the sum of, you can take extra variable sum. Rather than taking extra variable sum, I'm just trying to manipulate same target. So that hope you are able to get it right. Everyone, please. You are able to get that point, right? I don't want to take additional sum variable to find out the current sum elements. I just manipulate the target. Hope you get it right. Everyone, please. Okay, let me move this here. Okay. Okay, so now what is our job? Candidates, target, and we also need a current list, current combination. You can say current combination. So yeah. So what is the base case? So whenever your target is less than zero, it means you are out of the, so you can't consider further more. So you can simply return. And whenever your target is zero, target equals zero, it means you found the result. So as you found the result, let me take a global variable called result. New array list. So you can have result dot add of new array list of given current combination. So as you found it, right? As you found it, you don't need to explore further more. So obviously you can return. Perfect. So you can return. Fine. So now what is our job? Let's say here, what is our job? So first we are starting. This is my start. So initially you are giving index zero, right? So you are starting from index zero and which is moving towards this candidates dot length and start plus plus. And what is our job now? So this is a traditional backtracking problem, right? So first what you do, you will add this current value to the subset, current combination. So add of current value, it means which is candidates, right? Candidates of start. Okay, as you consider the current value, definitely you need to subtract that value from the target so that let's make it possible. So I'm trying to subtract from the target and so one thing for sure, I need to subtract the current value from the target. Okay, so target minus this current value is current dot start. Okay, this is fine. And I'll also pass same current combination and I'll also pass same candidates. And what is the index to be passed? Can you tell me? This is more critical point. What is the value to be passed as an index? Same, right? Same start. Why? Because we are repeating the combination until it is successful. If it is not successful, right, it means whenever it is less than zero, whenever target becomes less than zero, then it is not at all, current start is not at all valid case. Then you will pause it. Then what you do, whatever current start you added into uh, the current combination, just remove it, size minus 1 after removing it, and what is happening, start becomes start plus plus so that it is going to the next value. From the next value it will try to do it. See, man, we have solved around 4 5 problems, right? except this except this 8 to 13 line, remaining all lines are same, right? So that's how backtracking works. So the backtracking is completely depends on the base cases, how you derive and how you want to return the business logic. At line number 17, target minus candidates of start, right? That was the business logic. Okay. So now what you can do, just simply uh, you can simply call this backtrack method with index 0 and candidates and target and new array list and return result. Okay, run it. then just simply submit. Perfect. So this is how it works. Uh, and let me find one interesting problem. I'm trying to, I have noted it down, but somehow I missed it. Um, yeah, this is the one. Yeah, as you get bored with backtracking, so let me try to deal with it. This is really interesting problem. Uh, yeah, let's understand the problem statement. Then we will try to come up with the solution. Uh, but it needs a knowledge of backtracking. But when you apply backtracking solution, definitely it will exceed the time limit. But that's a brute force way to solve it. Uh, so the task is what is trying to say is we need to find out max product of first and last element of a subsequence. So you are given an integer array nums and the integer yum. Return the maximum product of first and last element of any subsequence. I think we have less time, right? This may take little time. Oh, okay. Let me explain the brute force way so that you can try the optimistic solution. So what he's trying to do is you want to return the max product of first and last. So let's say what the problem statement says, then we will see about the possible solutions. Okay. Let me take something smaller input, all or larger. Okay. Let me take this one. So 1, 3, -5, and 5, 6, -4. And what he's trying to say is you will be given an input, you will be given an input array and the subsequent size which is equal to 3. So you need to generate this input array into possible subsequences of size possible subsequences of size then then this is subsequent size. Okay. Then we need to return the maximum. What could be the max product of first and last? So let me tell you one thing. Let me explain it. So what do you mean by subsequence? For example, you have 1, 2, 3. So subsequence means it can skip the current is it can this is index 0, this is 1, this is 2, right? So I can take 1. I can consider 1 as a subsequence. I can consider as 1 and 2 are subsequence. Why? Because they maintain the same order. Okay, I can also consider 1, 2, 3. This is also subsequence because they maintain the same order. I can also say 1, 3, which is also subsequence. Why? Because this is also maintains the same order. This is at index 0, this is at index 2. So the subsequence means you can skip the elements in the middle, but it should maintain the same order. So that's what I'm trying to say. It should maintain the same order. Similarly, 2 is also subsequence because it is starting from the index 1. And similarly, 2, 3 also subsequence because it is 1, it is 2, index 1 and 2, and 3 also subsequence. So what he is trying to say is you need to generate possible subsequences. Okay, so let me generate subsequences from this input. Okay, so how does it look like? So let me start with let me take some input something smaller so that I have 3 minus 1, 5, uh, minus 5 and minus 8. So let me take this way. Uh, let's say how many subsequences you can generate of length 3. So one is this one. So I can simply generate 3 minus 5 plus 5. And what could be other possibility? Let me skip this. If I skip this, definitely what will happen? I need to extend furthermore so that it is going to be 3 plus 5 minus 8. And if I skip this, let's say if I skip this subset, then I can consider these 3 so that it can be 3 minus 5 and minus 8. And do you have anything? If you tried skipping this element, you tried skipping this element. If you skip these two elements, then subsequence will be 3 comma minus 8. But they are expecting max length as 3, so that this is not valid. So obviously you can, okay, where is it? You can avoid this. Now let's move further. Now you are done with solving all. Hope you are able to get it right. So 3 minus 5, 5 and minus 8, right? So what I did, so first I consider these three values. So that's why I got this one. Then what I did, so in the next sequence, I try to skip this element. So if I skip this element, how does it look like? Uh, how does it look like? So simply it is 3. As I skip this element, so I can maintain the order. So 3 minus 8. That's why I got this one. Now let's say in the same input, I want to skip other one. So I skip this one, right? So earlier I skipped this one so that I got 3, 5 minus 8. For example, if I take the same input, which is 3 minus 5, 5 minus 8. First I skip this element, or let me skip this one. So if I skip this one, so which is going to be 3 minus 5 minus 8. So this is what I have drawn here. Okay, hope you are able to see. So I get this one and this one and this one. So we seen it. Now let's say you are done with this possibility. Then we are trying to see with this possibility. So with this element, obviously you have only this minus 5 plus 5 minus 8. So you cannot skip any element in the middle. So that obviously you end up having only this. So it means you generated four subsequences of size m equal to 3, and we need to see what is the maximum product of first and last value. So okay, so this is my subsequence. So first and last value maximum product. In this case, 3, 5, right? So the maximum product, the first and last value product is 15. In this first and last value product is minus 24. Here the first and last value product is how much? Minus, did I repeat it? Okay, same thing. So minus 24. And here also the first and last value product is uh, 40. So we need to return the max product, which is 40. So do you understand the problem statement? Then how do you come up with the solution, right? So that is the tricky part. That's a tricky part. Uh, but can you generate subsequences of length? So one way is we can generate the subsequences of length 3, right? We can generate a subsequences of length 3, and we try to find out a product of, this is what's generating the subsequence of length 3, and we try to find out a product of last and first and last value each time. And whenever I get a max product, whenever I get a product, so each time I try to get a product, and I'll store that value into the memory, and I can return that final product. So assume that I'm going to write some backtracking logic, so which is going to generate a subsequences of length m. And whenever I get a subsequence, I'll find out the product of first element and last element, which will be stored into my global variable. So initially my max is 0. Here I get 15, so that I'll replace with 15. Here I got minus 424, but 15 is greater than minus 24, so that I don't consider. This also I don't consider. When I come here, When I come here, so definitely it is 40. So which 40 is greater than 15. So that 40, I will simply return 40. Now can you tell me how do you generate the subsequences? So it's a brute force solution, but we'll come up with the optimistic one. But if you want to generate a subsequences, how do you do that? So what is the input we taken? 3 minus 5 plus 5 minus 8. How do you generate subsequences, man, please? Or you must, yeah, no, 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 I'm not talking about this one. How do you generate this one? Subsequence. That, yeah. Hmm. No, first of all, do you think subsequence is a variant of subset problem? Subsequence is an variant of subset problem. Do you think? Let's say what are we trying to do here? So I start with index 0, right? So we have value 3. Then what you go? You go on to index 1 and we have value 3 comma minus 5. Then we go on to index 2 and we have value of 3 minus 5 and plus 5, right? So it means you found a variation, you found a subset of size m. So you should not go furthermore. If I go to index 3, right, then it becomes 3 minus 1, 5 minus 8. But this is exceeding my subsequent size, right? So definitely I should not move furthermore. So it's time to break it. Okay, it's time to break it. So let me move these values here. So it's time to break it, right? So it's time to break it. How do you break it? So it means you found a, what do you think? So you found a subsequence, then you find out a product of these two values, which is 15. Okay, so which is 15. Then you stop it, right? You stop it, then you backtrack. Once you backtrack, you remove the last element, you get this one. Then from one, you try the possibility of index 2. From one, you try the possibility of other index, which is index 3. If I try to do index 3, then I will add index 3 value to this, right? So it becomes 3 minus 1, again minus 8, right? So because this is index 1 having this subset, so I'm adding index 3 value, so which is minus 8. Now, if you closely see, the again it is reaching the size of m, so which is going to be minus 24, but which is not greater than 15, so that my value is remains same, so that I don't need to move further, so that I need to backtrack. So whenever I backtrack, I remove the last element. Now, if you closely see from index 1, we have seen index 2 and index 3, there is no other possibility, so that it's time to move further. So you can remove this element so that you get minus 3. It means from index 0, you've seen the possibility of moving on to index 1. Let's move on to index 2. Yes or nobody? Please. Because from index 0, you've seen the possibility of index 1, right? So let's move on to index 2. So at index 2, you have value, it means earlier you have 3 and index 2 value is 5. Then that's it. So you take an index 2. Again, you don't have other options from index 2. You can blindly move on to index 3. So it becomes 3, 5 minus 8. If you closely see, you have reaching the size of m. So that obviously you take the product of these two, which is minus 24, which is not greater than 15. So that I'll keep it same. Now, if you closely see from index 0, I can move on to index 1 and index 1 and index 2. So let's try to index 3. You can better optimize this, but okay. So 1, 2 is done, 3. So if you go with 3, obviously it becomes 3 comma at index 3, you have minus 8. But this subset size is not equal to m, so that you don't consider this is done. You can't even go further because you are reaching out of the array. So you can't go, you can't even reach further. You are reaching out of the array. So which means we have seen all possibilities of index 0. So let me try starting with index 1. So if I start with, because your backtrack will do first 0, first it sees the possibility of 0, then it sees the possibility of 1, 2, and 3, right? So index 1. So if I go with index 1, so you have -5. Then you move on to index 2, then it becomes -5 comma +5 because it is 5. Then you move on to index 3, it becomes -5 comma +5 comma -8. So it means it is reaching the size of m, so that you find the product of this, which is 40, which is greater than 15, so that you update to 40. Now you don't need to go further. So from index 2, you tried possibility of index 3. So there are no other possibility to explore because it is reaching out of the array. So simply you will move on again to the parent index 1. Again from index 1, you tried possibilities of index 2. Let's try possibility of index 3. Okay, so let's try possibility of index 3. Ideally you can break it, so I don't want to make it complicated, so you don't need to explore this. You can apply a math. Does it, if I go further, does it generate a subsequence or not? So that you can try it out, but no worries. So here you have -3, right? So my index 3 -5, and index 3 value is -8. Now, of course it is not at all generating it, so it is not equal to m size. You don't consider it. Similarly, if I try with index 2, obviously from index 2 to index last one, you have a length as what, buddy? You have length as 2, right? From index 2 to, if I try with index 2, so you can take value 5, then you move on to index 3, it becomes 5 comma 8, but it is length is 2, which is less than 3. So you can skip this iteration. Similarly for index 3 also, you don't have any other possibilities. You can skip this iteration. If you closely see, out of all these cases, we got 40. That 40 is our result. Do you understand this, everyone? Banu, did you understand? So it means it's a subset problem, man. It's a subset problem, but it's a conditional problem on subset. Uh, so definitely, what is one? At least we can at least what do you say? Okay, so let me write a blind brute force. Then we can optimize that brute force. Later we will come up with the optimistic solution. So I'll tell you the hint. Then you can try by your own. So what I'm trying to do, I'm trying to private white subset. Okay, subsequence, right? Subsequence. So which is going to take index, and this is our integer nums, and this is our yum. Okay. So now what is our size? And we are also having current sequence. Uh, so this is our current sequence. So this is our current sequence. Now, can you tell me what is the time complexity of this, please? What is the time complexity of this? Tell me, please, yeah. Array, it's a subset problem only, na? Why are you getting confused? Is it not? Is it not? Is it not a subset problem? It's a 2 power n, right? And yeah, so the max size of the subset you can copy is m, right? So it is m into 2 power n. Okay. So now let's move on. So what is our job, right? So whenever your current sequence size, which is equal to m, then it's time to find out the product of first and last value, right? So you can take current product, which is going to be sequence dot get of 0 into sequence dot get of size means m only, na? So m minus 1. Then you can yeah, I know this is a bad way of declaring the variable, but let me do that. You can consider it as max product equal math dot max of max product comma. No, 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 no. నువ్వు వెళ్ళి సార్ అని చెప్పు వెళ్ళి go. Yeah, yeah. No, max product equal math dot max of max product comma current product. Then you will just return. So this is fine. You already did it. Then what is our job now? So we will go further and what we do. So we will have a start from index, start less than nums dot length and start plus plus. And now let's say what is our job now? First we will add current sequence to start, current start to sequence, which is nums of start. Then we will move on to the next index, uh, start plus one, nums. It's like a blind logic, right? So after writing couple of lots of code, you feel like uh, you get with absent mind also. This logic you will get through absent mind. Done, right? Uh, let me let me call this subsequence with zero nums yum and sequence and finally return max product. Better let me take it as integer dot min value. Okay, this man considering it as a long, so let me consider it as a long because there could be higher values. So here also I'll consider it as long. Perfect. So let me run. What's happening? Okay, okay, I will. This is one issue and subsequence start num yum sequence. Index we passed, nums we passed, yum passed. Okay. Sequence means it's a new empty array. Sequence dot length size, right? So yeah. So obviously it is successful, but if I submit this, definitely it will give an error. Uh, I am telling you, you need to optimize this brute force. And tomorrow I'll tell you the optimistic way of doing it. But I'll give you any hint. You can solve this in sliding window with linear time. But to get that thought right, you should be very good in backtracking brute force so that you can get that thought. Try applying that concept. But you can improve this furthermore till where you can improve furthermore. So what do you think this algorithm needs? Where do you think this algorithm is needs this algorithm needs improvement? Tell me, bro. Tell me, yeah. Where do you think this recursive stack is needing improvement? Let me add that. So you have 3, 5, 5 minus 8, right? Oh, we didn't validate with our input. So let me add that input also so that what is our thing? 3 minus 5, 5 and minus 8. And this size is 3. So let's run. So you get value as 40. Okay, so tell me, where do you think this needs improvement? I want to hear from you. It's okay, it is able to succeed, but do we need to explore all possibilities? Do we need to explore the possibilities from index 2? Why? Because if you explore the yes, so if you explore the possibilities from index 2, right, there is no point, right? Because Even if you do from index 2, the max length you will get 2, but we need m equal 3, right? So what do you mean? What do you understand? So uh, the size is 4. So if you take this size n equal to 4, so because there are 4 elements, till where you can till where you can explore m equal 3, right? So it means you can see, okay, you can derive that mathematical formula, but let me explore conceptually. One thing for sure, from here you don't need to skip. You need to skip it because there is no point of exploring it, right? So it means what are the possible subset starts you can have? 0 and 1 only, right? So with if you start with index 0, you can generate subsets. Similarly, these are the possible subsequences. Sorry, these are the possible subsequences. The starting point of the possible subsequences are this one, right? Yes or nobody? So I am also giving a hint for optimistic solution, but you try it. So it means the start can be 3 or start can be -5, correct? And what are the possible ends? Possible ends, man. These are only, na? These are only be possible ends points, right? Yes or no? Correct, na? So it means when you start with 3, the possible end 5 comma -8. When you start with -5, the possible ends 5 comma -8. It means this can be one possible end, 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 or 3 into 5 or 3 into -8. You can see here also -5 into 5 or -5 into -8. Here you got 15, here you got -24, here you got -25, and here you got 40. I think we were, yeah, so here you got 40. So this is your 40, which is expected, right? Now you can apply sliding window with this concept. Try it out. If you need help, then tomorrow we can discuss. I think in recursion somewhere we did mistake, man. That this 25 we didn't get it right. Where is it? Where is it? Where is it? -5 to start. Somewhere, yeah, -5. Yeah, -5. No, no, no. Okay, okay. Yeah, this is invalid, right? Correct. This is invalid, right? So for -5, you get end as -8, na? So this is invalid. Just think about it. So you don't get, if you start with -5, na? If you start with -5, and this will come into middle, so the end you will get -8. So that these are the possible results you could have, out of which is 40. Okay, so it needs some, you need to put little brain on it. Uh, Try solving by yourself. If you can't able to do it, let me know tomorrow. We will try to do it. But this can be solved in linear time. Let's see how you come up with. Thanks for your time. See you tomorrow. Uh, Solve all the problems, man. If you don't solve it right, there is no point in discussion, right? We are done with it. So, are you better solve these two problems, practice problems? And if you are okay, you can solve 93 and 301. If you are not being comfortable, then ask me. I can give you the algorithm so that you can try it out. That's it for today. See you.